We have a company that produces plastic bottles, and they're unable to check every bottle for defects. So instead they check samples of bottles each day and look at the proportion of defective bottles. They'd be interested in estimating the population proportion of defective bottles each day, which would be called P, and they would look at that by taking a sample of bottles. We have some information that they have a sample of 400 bottles taken and they find that 16 are defective. But what we really want to look at is if we hadn't taken that initial sample and they wanted to get a confidence interval for P, how large a sample should they take if we were doing a 95% confidence interval and we wanted a margin of error of just 0.01. So we have a formula for solving for the sample size based on a desired margin of error, and it's just a manipulation of the part of the confidence interval that gives the margin of error and solving it for n. And what it says that we do is we take our z value, which will depend on our confidence level, and we square it, times p times 1 minus p over the amount of error we want squared. So we can replace p with either a guess based on the fact that we took a sample, or if we don't have an initial sample taken or we don't want to use that information, the conservative approach, resulting in the largest possible n that you would get, is to replace p with 0.5. And so we're going to do that here because we're saying that we aren't looking at considering that initial sample. So with 95%, our z is 1.96, so we square that. We're not using initial samples, so p is 0.5. And we're told that the amount of error we want is 0.01. So we want to square that. And always note that the error is half of the width of an interval because we add and subtract the error to our middle value. So what we'll get here if we calculate this value happens to be exactly a whole number. If it hadn't been a whole number, we would round up to the nearest whole number. But what we get is a sample size of 9,604. This will be larger than if you used any other guess for P. When we plug in P.5, you get the largest possible N, considered to be the conservative approach.